So thanks very much. I suppose the first thing I'd like to say for inviting Ecological Building Systems to give this short presentation on the topic of insulation. I think as a company, we're fairly well positioned to give our insight anyway. We may not know everything. I'm certainly learning all the time, but we know quite a bit about the insulation market because we supply many different types. And whether that be new build, for example, you see a little picture of a fella holding a handful of cellulose newspaper. There's no reason why that couldn't be used in someone's attic, or sheep wool, or even in retrofit and traditional buildings and things like that, because we also supply things like wood fiber and calcium silicate, which is just a fancy name for a lime aerated board, or lime-based undercoats, lime-based cork thermal plasters. So we'd have a broad overview of insulation and the market generally. I suppose my own experience, before I get into the topic, I spent a long time studying topics around this broader topic of energy and comfort in construction. And, from studying things like green engineering or sustainable construction or energy management, it's kind of given me a good insight into energy efficiency in buildings and appropriate building methods and things like that as I've gained experience over the years. So, but I come from a trade background originally, but I spent about 10 years in and out of college over time, partially through TUS, as it's now referred to. And, so you're never finished learning in these kind of things, I find. Our company itself, Ecological Building Systems, we're a division of a parent company called McCann & Byrne, and they've been around since about 1906, and they're a generational company, still owned by the same McCann family today. But around the year 2000, their managing director, with a lot of foresight, as he was working with business partners out in Europe and stuff, he would have saw a move towards a shift in the market in insulation and in high performance building. And so he started at that time sending around little faxes to people and asking them, did they want to be involved with a little company based in Meath in Ireland? And one company came back at that time, and it was our airtight product partner. I'm going to be speaking about airtightness in a later event next week, but they came back, and then from that we partnered with many of the insulation providers you see listed on the side: Gutex, Dyson, Calcitherm, Thermojute, and so on. So we have multiple partners, and we've gained experience over the 2 decades that we've been around. So we'll jump straight into it, and we'll take a look at what are some of the current trends that we see out there in terms of insulation. And one of the big trends that most people will see can be directly related to the news you watch every night. So we're all seeing things like big floods in Pakistan and, droughts in Spain and fires breaking out in Canada and Greece, the mountains going up on fire. And, so it's a worldwide climate emergency. There's no denying that, in my opinion. And as a result, every sector has a responsibility to drop its carbon emissions, and insulation is no different. So particularly in Europe, the EU has committed to be the first climate neutral continent by 2050. So in other words, the first one with net zero greenhouse gas emissions. Where does building fit into this and insulation? Well, the overall emissions are partially from transport and agriculture and other sectors, but a large proportion of it, in fact, 40% of the total energy use comes from the building sector. And of that entire 40%, about 70% of that stock of buildings is very, very inefficient, with minute amounts of it renovated every year. So the existing building stock is offering really, really high potential for carbon savings, because if we can make them more energy efficient, they'll use less fuel, and therefore there'll be carbon savings. But we can't take our eye off what we're going to insulate them with in the first place, because that in itself has an embodied carbon content. So the EU is heading into the renovation wave headfirst as part of the EU Green Deal. So they're planning to tackle a lot of retrofits, deep retrofits and stuff like that. There's going to be a lot of building material going at this. So, and likewise, this becomes more relevant later in the presentation, 26% of all EU buildings are pre-1945, which means they're of traditional construction. So not every insulation type will be appropriate for this amount of buildings. In Ireland, that accounts for about 250,000 of our homes in our built environment. And in the UK, that's about 7 million. So we really can't take our eye off the type of material that's being used, because we want to try and save carbon, and also how appropriate is it for the built environment that we're applying it in. So what we're seeing as a key trend is the growth of resource efficient building methods, and with that, the types of material that's been put in it. It's really due to the growing awareness around climate change. So I just put up this slide just to pull out a couple of the resource efficient building methods that people are becoming more and more familiar with all the time. And these types of solutions help to de-skill the manufacture of buildings and the huge demand that's out there. So, you know, methods like CLT, and there's a great little project by John Barry Lowe of Eden Architects in the bottom left corner there. It's his own house. And we're seeing the popularity of this method of construction growing. We're seeing straw as an insulation, as a primary insulation and a building method growing and growing, because it's an agricultural byproduct, and around 25 million tons produced every year, 10% of which will be enough to insulate 500,000 dwellings per year. So you can see there's huge potential in this otherwise wasted material. And, you know, timber frame and off-site construction and stuff like that means they're looking for easier and easier ways to pre-prepare these types of buildings with insulation. So it's kind of having an influence on manufacturers innovating on what's out there. I think at Ecological Building Systems, you know, we've been promoting methods like this for a long time, and the use of materials like hemp and wool and wood fiber in place of carbon intensive synthetic alternatives. So like, if you have a building method that by weight can sequester 50% of its own weight in carbon, then the last thing you want to do is to put in a very energy intensive insulation into that. You want to try and combine it in a resource efficient way with something like straw or hemp or cellulose or wood fiber, etc. So the popularity of this is growing and growing, and emerging standards like the Home Performance Index is helping to drive things like sustainability in the built environment also. So it's the outcome is to incentivize specifiers to employ more efficient design methods and building materials generally. Another key trend is the uncertainty that surrounds the fuel crisis that's happening throughout Europe. So as the pinch is put on everybody's pockets, we're starting to see the importance of conserving energy as much as possible. Now, the energy I'm referring to there is primarily the operational energy it takes to run a home or a building for that matter. But the problem is that our building regulations have already pushed us to the point where we're nearly passive. So NZEB and passive is very close in terms of U values and thermal bridge free construction and air tightness and stuff like that. They're not the same, but they're approaching the point at which we're scraping the bottom of the barrel of operational energy savings. So it's important that even though this has become the norm, we can't forget the other half of the equation. If we're saving all of this energy already by the fact that our buildings have become so energy efficient, A1 rated or passive, then we have to look at what we're building from. So if we're going to be putting energy intensive materials into the building, they have a huge carbon potential. So we have a chance to reduce that and to apply the other half of the equation. Another key trend that we're seeing is the education and training that's going on out there in the market. Because of the government targets, as it shows down the bottom part of my slide, you know, we intend to retrofit 500,000 homes as part of this renovation wave. So there's a huge demand being placed on the industry, and there is a skills shortage out there. And what you're seeing is the industry reacting to the skills necessary for retrofitting of insulation and the application of high quality installations, because it would be very ironic if we had to retrofit the retrofits in 10 years' time. So, you know, bodies like LOETB are running great courses, and I know TUS as well and Atlantic Technical University, They've even got postgrad courses in circular economy for the built environment and retrofit management, and all of this ties back into the demand that's out there now in the market. So some of the common issues that we experience as insulation suppliers dealing with manufacturers in mainland Europe and the UK are price inflation and the supply chain issues. So, many manufacturers are relying on the supply of oil-based products, petrochemical-based products, and this type of fossil energy-dominated building material production has a lot of industries in crisis at the moment. A lot of, even for companies that are producing more sustainable raw materials, like, for example, hemp manufacturers in mainland Europe and Germany and France, things like that, they're relying on Russian gas for production. So as the price of gas goes up or becomes unavailable, the price of the raw material goes up in tandem. So what we're seeing this across the board in terms of material supply, and everybody's very familiar with this. Natural materials seem to be, excuse the pun, a little bit more insulated from it because the raw material itself is not heavily reliant on a scarce resource. So from that point of view, we're seeing a big difference between the price inflation for some petrochemical-based materials and some natural-based materials, and the price is beginning to kind of equalize a little bit. It would have always been a case where the more natural products were seen as the expensive option or the desired option, so the expensive option, but it's kind of becoming more on par. So global factors are really influencing the market price, and this has been compounded by the war, of course, that's going on at the moment, but COVID-19 has created a huge amount of built-up demand due to the closures that were suffered globally. And now that everything's reopened again, there's a huge demand and competition for everybody's competing for containers. So even if you can get your product, it's difficult to ship it worldwide and to move it around because there's a worldwide container shortage. So the price of transport has also gone up, which is affecting the price to the end user. So this is one of the key issues in the insulation market, and I'm sure many other building materials and systems. Another key issue that I'm personally experiencing on a frequent basis is some of the insulation grants that are available at the moment and the contradictions to how they're applied in traditional buildings. So as it says, look, many modern thermal insulation systems, they have really, really high vapor resistivity, and that can reduce drying ability for solid walls. So if you were to use a system like what you see in the picture, like, the phenolic boards with the dot and dab adhesive, you press that up against an old brick wall that has single leaf and it's relatively energy inefficient, there's a high likelihood you'll trap moisture behind that board, or you'll allow it to infiltrate behind the board into a cold pocket where condensation may occur, and then followed by all the issues and problems that can come out of that. So as I said before, it would be a shame if we had to retrofit all the retrofits, but in the case of some of the grants that are available, like for example in the Warmer Home Scheme, I know that there are changes in the works and specifically related to traditional buildings. But as I said, we have 250,000 of these to do. So at the moment, the problem is homeowners are sometimes seeking the grant aid package for internal wall insulation, and they're being advised, of course, that the product must have an NSAI agreement certificate. This is a huge challenge for European-based products that already comply with the European construction product regulations. They're CE marked, they have DOPs, and in many cases they have European technical approval, which would supersede anything. But because they don't have NSAI agreement certificate as an Irish stamp, that's not necessary for the manufacturer, they're being taken off the table. So people cannot use what would be deemed to be the appropriate solution, and they may be forced into using something that's less appropriate simply because it has that cert. So this is a thing that's turning slowly, apparently, a bit like the Titanic at the moment. But hopefully in time they'll have rectified this issue. But we do have a responsibility, if we're insulating these older buildings, to insulate them appropriately. So this kind of comes back to the responsible retrofit of the older building stock that we have, because we've got a huge amount of it. It's outlined really in a lot of key documents, and here's one of the standards that people often refer to, and it's the conservation of cultural heritage. guidelines for improving the energy performance of historic buildings. So in this, it says that we need to recognize the significance of the specific values of these constructions and prevent interventions or exclude interventions that would, compromise how these buildings act in terms of moisture and things like that. But simply because a person is applying for a package of a grant, it may actually force them into a situation where risk is quite high. Modern buildings are not designed like the older buildings. So modern buildings have capillary breaks and like by way of cavities in walls, or they might rely on DPMs and things like that. So they're moisture blocking forms of construction. Whereas on the other hand, the older buildings are largely characterized with walls that need to be in a constant state of evaporation and absorption. So they're constantly taking on moisture and letting it go and stuff like that. And if we compromise that anywhere, you could end up in a situation where you're causing decay to an older building. So this is a problem for insulation suppliers to try and get this message across to homeowners when there's an attractive grant package pulling them in a different direction. So as I said, great care is needed to ensure the chosen thermal solution doesn't compromise and lead to moisture accumulation. So a lot of this is kind of an ongoing thing, but we try as suppliers to demonstrate how appropriate something is by way of looking at it with a risk assessment according to the recognized standard, which is EN 15026. So future trends and where the industry is going, the insulation industry is going. And as I said, we certainly don't know everything, but we're learning all the time. But what we would see as insulation suppliers would be that the legislation also is beginning to move in the direction of low carbon construction. Insulation choices, they really affect the carbon footprint of the building in terms of embodied carbon and even the operational emissions, because if you put enough of it in, you can reduce the operational requirements. So insulation can be a contributor to the embodied carbon of the building or a carbon sink, one or the other. And if you look at the insulation choices here from Architecture 2030, I just thought it was a nice graph to include because it's simple. It's the carbon impacts of insulation. If you're using something like EPS, the orange bar to the right just shows it has a high carbon impact. And on the other hand, at the other end of the graph, if you look at straw bale, it has a negative carbon impact. So it helps to lock in carbon into a building. So this is why legislation in the EU as a whole is moving in this direction, and other EU countries are following suit very quickly. So when you use natural materials and blown-in applications, it's the best way to reduce the embodied carbon of the insulation, but also the construction system as a whole. And it helps to complement things like the modular forms of construction or the offsite construction, things like that. So as I said, we want to be pushing the fabric as far as possible, but we're kind of in the bottom of the barrel now. We've kind of done that. NZEB is like, we put it this way, in 2019, we only moved on the BER scale, if you want to look at it that way, we only moved from A2 to A1. That was a nice energy saving, but it's still, that's how incremental it's become. So we're kind of scraping the bottom of the barrel. So we've got to now think about the materials that we're using that's going into them. So resource efficient principles means lower operational and embodied CO2. Generally speaking, as a construction method, passive house is seen as the gold standard, really, and something that all building regulations are kind of trying to aspire to be like, in my opinion, should be. But yeah, so we need to look at it a few different ways, but there's a nice little quote there on my slide from Dr. Richard Hegarty from UCD, where he kind of said, NZEB is close to zero, which would be zero carbon, but not close enough. And that's in reference to the embodied or the upfront carbon of the materials you're putting into it, and insulation makes up a huge proportion of that material. So, and of course, circularity is becoming ever more popular as well. So being able to reuse and be resource efficient within the industries, the manufacturing process and stuff is becoming more popular as well. And legislation is driving us in that way. And in fact, the Circular Economy Act only came in Ireland a couple of weeks ago, officially, I believe. So just some key facts about some of the natural insulations and the future trends and why it's going in this direction. If you look at, for example, I just pick out one of those, cellulose insulation has the highest amount of recycled content compared to any other form of insulation. So it's quite straightforward as to why cellulose may be used. Now, it just so happens to have attractive thermal values and ability to buffer moisture and things like that as well. But all of the natural insulations, I could pick out 20 from the market, and I could select a lot of benefits and key characteristics from them. I'd struggle to do that with simpler material or petrochemical based material. I would struggle to do that. I'd just be looking at something like thermal conductivity only. So natural materials offer a lot of benefit. And when you combine natural material with good planning, and there's a hell of a lot of potential for carbon reduction. And by that, I mean, sorry for another graph, but if you just look at the bottom axis for a moment, if you're moving towards the left, in the planning stage, the carbon reduction potential goes as high as 100% if you move up the graph. So if you build nothing, in other words, you're not using any carbon, but that's not practical. So maybe we just build smaller buildings and then we're saving a lot of carbon. Or we build clever, so we put natural insulations into the product as you come down the screen. And all of these things have carbon reducing potential. So if you use carbon clever materials with clever design, there's a huge opportunity to tackle a big proportion of the problems we're seeing. This is a future trend that's, it's a present and a future trend, but materials are really going to require a lot of future third-party testing for VOCs, healthy building standards. They're all positive steps for specifiers of insulation materials, but it's certainly something like declarations and standards to adhere to, like the Living Building Challenge and third-party testing in Sentinel House and for VOC content and stuff like that. These are all things that a specifier can read and can say, well, okay, now I know what potential harmful impacts to human health a material has, and likewise how energy intensive a material is becoming. So we're all aware of EPDs, or environmental product declarations. Insulation providers are now producing these by way of, as a source of transparent information, really useful for everybody, but specifiers mainly. But if everyone is writing it the same way, which they should be, but there's a lot of nonsense out there too, I have to be honest, yeah. But if everybody is trying to declare what's in the material, then people can make judgment calls based on the values produced and the values transparent to them. Dyson, the company that produced this one, for example, they produce our thermal plaster range, and they have a APD available for their entire family of products. So you can easily go in and say this one has more upfront carbon emissions than this one. So it's just a way of maybe trying to reduce that ongoing. But this is a future trend that's only going to keep getting popular, more and more popular. So I don't know how I am for time. I think I've gone a little bit over, so I apologize. But thank you for listening. And we have a load of different services at Ecological Building Systems, but as this has been recorded, there's our contact details. And if anyone likes to get in touch, feel free to do so.
Perfect. Thanks very much, Joe. That was brilliant.
No problem, Stevie. Thanks very much.
We just there's no questions. Just everyone saying excellent presentation. I agree. It was very informative and very interesting as well. I like the idea of the embodied carbon being brought into the kind of way we think about building buildings as well. So again, thanks very much, Joe, and thanks very much to everyone for joining us today. These recordings will be put up on the YouTube channel once we get around to fixing a couple of technical issues we have with it. And yeah, so we will have another 2 webinars next week from Wednesday and Thursday, again, same time, about 1:15 to in and around 20 to 2. So again,
I might see some of you guys again. I think I'm delivering the one next Wednesday, I think. On airtightness, is that the one?
Yeah, exactly. Yeah. That's next week.
So maybe I'll see some of you guys again.
Exactly. So yeah, if you have any other questions, I will forward on the questions on to Joe, and we'll try to get them answered for you. So again, thanks very much to everyone for coming, and thanks very much, Joe, and we'll see you next week.
Thanks, guys.